guys! Alright, today we're talking about solving systems of linear inequalities. Bum, 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 bum. So, here's an example. Marcus has to watch what he eats. His doctor told him to eat between 1,500 and 2,000 calories per day. The doctor also wants him to keep his daily fat intake between 60 and 75 grams. Draw a graph that describes these eating habits. Well, we don't have an independent or dependent variable, so I'm just going to put calories down here, and I'm going to put grams of fat on the y-axis. Okay, so let's take a look at what we have here. It says that he needs to eat between 1,500 and 2,000 calories per day. So let's just say that's 500, 1,000, 1,500, 2,000. So this is 1,500, this is 2,000, and this was 500,000. All right, so there we go. He needs to eat between 1,500 and 2,000 calories per day. So I can graph that like this. This is 1,500 and this is 2,000. Okay? So he needs to eat that much. But he also has this other restriction according to his, well, I'm going to go ahead and shade in between. So let's highlight in between those two right here, because he can eat between, ignore the overlap, it should be completely straight. It's just kind of hard to do that. Ginger. Shh. Okay. So we have, the doctor also wants him to keep his fat intake between 60 and 75 grams. 10, 20, 30, 40, 50, 60, 70, 80. So right here is 80, so we want to be right about there for 75. So I'm going to go ahead and graph that like this. Oops. All right, and 60. Okay, and I'm going to pick a different highlighter color. So I'm going to pick blue. All right, so it needs to be between 60 and 80, 60 and 75 grams of fat. Okay, so we've drawn this little picture here. Suppose Joshua eats 2,100 calories, but only 55 grams of fat. Is this an appropriate intake of calories and fat? Well, 2,100 is over here. And 55 is like right about there. Is that in my overlap area? Because I needed to have him right in this green area, right there. That's my solution. Okay, where they overlapped is my solution. So that point is not in my solution. So is it an appropriate intake? No. How do you know? Because he needs to eat fewer than 2,000 calories per day. So it is not in the solution set. Okay, so our solution set was this green area right here. Okay, so how do we solve a system of inequalities? First, graph one inequality and shade, which is what we were doing last class. Second, graph the second inequality and shade. That's the second part. The solution is where the two shades overlap. Okay? Alright, so here we go. Example 1. Solve the system of inequalities by graphing. So I'm going to do the first thing. I'm going to graph y is less than 2x plus 2. So start at 2, slope of 2, up 2 over 1, up 2 over 1, up 2 over 1. This is a dotted, I should not, there we go. Let me put dots, open hole, there's. All right, I'm going to make sure I'm really going to have a good graph. And I'm going to dotted line. Okay. Y is less, so where do I shade? If you said below, you are correct. Okay, so I want to make sure it's clear that I'm trying to get all the way to the line. And there we go. Yay for highlighters. Okay, next one. Y is greater than negative or equal to negative x minus 3. So negative 3 is my y-intercept. So it starts there. Negative x is up 1 to the left 1. So I'm going to graph that one at a time. All right. And I'm going to draw, here, let me get a few more here. Okay, this is a solid line, so I'm going to draw this line. Ooh, all right, and put arrows on the ends. And it says y is greater, so I'm going to pick out a different highlighter color. And y is greater, so I'm going to shade above the line. Now what's fun about systems of inequalities is you get to play with colors. Because see, look, what over here is my solution? Well, the solution is the set that actually changed colors, the overlap. I've got blue highlighter and yellow highlighter here, so this is my solution. So here's some examples of solutions in my set. The point 1, 2, 3, 4, 1 is a solution. Negative 2, 1 is not. Oops. Okay, so this one right here is not a solution. All right, so 4, 1 is a solution. Okay, so I'm looking at the green overlap area is the solution to the inequalities, the system of inequalities. Okay, so let's try another one. All right, this is y is greater than or equal to negative 3x plus 1, so I'm going to go to plus 1. And negative 3x, so up 3 to the left 1, negative slope, meaning it looks like they're going to slide down. And I'm including the boundary line. Oh, that reminds me, on the other one, here, the boundary line from here, well, not including this point, but from here down is part of the solution, okay? This boundary line is not because it's dotted. All of this boundary line is not because it's not in the solution set over here. This point is not included in the solution because this line is not included in the solution, okay? All right, so let's try that over here. I've got a solid line as a boundary line, and that means it says greater than that, so I'm going to shade above this line. Alrighty. Then it says graph the line y is less than or equal to negative 3x minus 2. So negative 3x minus 2 is like a 3 over 1. Right about there. All right. And it says y is less than. So I have to shade below. Well, where do they overlap? If you say they don't, you are right. So what's my solution? Well, they don't intersect. These lines are parallel, so they don't intersect. And these two areas don't intersect. So this has no solution. Isn't that interesting? A system of inequalities. Ginger. Shh. A system of inequalities can have no solution if their areas don't ever overlap. All right, let's try this one. Y is greater than negative 1. Well, in class we learned that we talked about how negative y is less negative 1 is a horizontal line. So we got that nailed down. And this says y is greater than negative 1, so I'm going to shade above the line. Close as I can get without going over. And the next one was x is less than 0. Well, less than 0 is this line right here. the y-axis. Okay, and I'm going to have to shade less than 0. So that means on the negative side, okay, well, where do I have my double overlap? Well, that's quadrant 2 over here, kind of. I mean, little overlap. Oh, it includes this piece right here, too. So this is the solution set right there. So let's see, we've got this point is a solution. 1, 2, 3, so negative 3, 2 is a solution. Okay. But this point over here, 1, 1 is not a solution. 1, 1 is not a solution. Also, 2, negative 4 is not a solution. Okay, so this is not a solution, this is not a solution, this one way out there is not a solution. The only one that's a solution is the one in the overlap. Okay, so tell whether the ordered pair is a solution of the given system. Well, just like we would have in an ordered pair in a system of equations, we're going to use the system of equalities the same way. We're going to plug, we're going to plug the point into the inequality. Okay, so is negative 3 less than or equal to negative 3 times negative 1 plus 1? Well, that tells us that it's 3 because a negative times a negative is a positive. Plus 1. Is negative 3 less than or equal to 4? Yes, because negative 3 is less than 4. Okay, let's try it again with the other inequality. Negative 3 is less than 2 times negative 1 plus 2? Well, is negative 3 less than negative 2 plus 2? Yes. So, this is a solution to the given system. That's a yes. Okay? All right. Okay, part B. I kind of got lost in translation here. All right, go ahead and we're going to plug this one in and to both inequalities. So is 5 greater than or equal to negative 1 plus 3? This says 5 is greater than or equal to 2. Yes, 5 is bigger than 2, so that works. What about 5 is less than negative 2 times negative 1 minus 1? Is 5 less than 2 minus 1? Is 5 less than 1? No. Okay, so this is not a solution. Okay? All right, so what to do next? Go to edmodo.com. Under the 6 Solving Systems of Linear Inequalities assignment, click on Turn It In, and in the response box list 3 things you learned and 1 good question. Unless you have more, if you understood everything, you don't have a question, just say so. And for class, you need to bring out your notes, your warm-up exercise, your warm-up questions, your cool-down questions, and your calculator. You should bring your calculator. We'll be doing more of those fun calculator activities in class. All right, see you guys later. Bye.